Well, good afternoon, everybody. My name's John Ryan, and I'm here to give a presentation called Securing VFP Applications Against a World of Hackers. Just a little bit about me. I'm actually a medical doctor for my sins, but I've been using Fox and Fox Pro since the Fox base days. I was Mr. Chen's first commercial user of VFP C++ compiler. And part of the reason for my interest in security of VFP applications is I actually have contractual obligations to look after people's IP. And as an example, the Australian, that's a government organization. If an unlicensed person is able to use their intellectual property because of my slackness, I actually become liable for their entire national license fee. Which is quite a disincentive to allowing that to happen. So I'm going to hide my mug and we're going to get going straight into this presentation. Just bear with me a second while I hide myself. Okay, hopefully these slides have now filled the screen. I apologize, this is not in slideshow mode because it's LibreOffice Impress. And when I put it into slideshow mode, it takes over the entire system and causes grief. So, the agenda today, it's surprising how often VFP people say to me that they don't need to really worry about these things I'm talking about because their applications are in environments that really no one's going to be interested in hacking and there's no intellectual property they want to protect. Hopefully I can convince you that that's not the case. So I'd like to share some jargon, because if you can use the jargon, then you can have an intelligent conversation about security. I'd like to show some VFP applications, and then I'd like to show you how you can hack things, or at least a subset of ways you can hack things. I wouldn't want this to turn into a how-to manual for bad players. Okay, so hacking, SBD, IAM. Hacking, I've used the quite broad definition. In common usage, people often imagine a hacker is somebody slightly onto a spectrum, sitting at their computer 24/7 in a darkened room and cracking into organizations. But actually, hacking has become a multi-billion-dollar business, and it encompasses a large number of factors. It's basically compromising systems and networks through unauthorized access to either accounts or the systems themselves. And usually it involves something like theft or damage of data or ransoms if you want to get access back to your system. It's not always malicious, but it usually is. And SBD is another jargon term, secure by default. That basically is saying that prevention's better than cure. Planning, preparing for the worst, not hoping for the best. So, secure is actually mainstream. If you look at Microsoft's attitude towards it, their newest 2022 ODBC driver now comes with a mandatory encrypted connection by default. And that is a breaking change. In order to use secured connection, you have to have a certificate installed in your SQL server. I don't think many small businesses will, but Microsoft's justification is that because of the emphasis on secure by default and the need to ensure secure connection, they have decided to make a backwards compatibility breaking change, which they realize will cause some disruption. But they're saying it's too easy to be exposed to malicious actors unless they do it. So that's becoming the mainstream ideology. Security is not really an optional extra or in, inverted commas, no one's going to bother attacking me. It's by default and it's becoming expected. As for systems being too small to be of interest to hackers, well, in 2019, over 40% of hacks involved small business. And in 2022, the consensus is that small business is now the #1 target. Incredibly, even Uber drivers have been targeted for hacking and held to ransom. But you often see, small shops and small businesses, people cracking into their systems and either blocking access and demanding a ransom or stealing data. In the meantime, big business has embraced SPD in a big way, and they have comprehensive IAM, which we'll come to in a minute, policies. And they've also adopted the same policy that was being adopted for hijackers back in the day. We don't pay you, we don't negotiate with you. So we don't see as many plane hijackings as we once did. That's their policy. So if it's no longer possible for this multi-billion-dollar industry to attack big business, or at least not as easily, what do you suppose they'll do? Especially when 42% of small and mediums are unconcerned about the risk and most have no plan. So I think a rational response for VFP is we don't need to go overboard. I've put a little quote there. If you're being chased by a tiger, you don't have to be the quickest. You just don't want to be the slowest. And what I'm saying there is what you want is for your application to be sufficiently hardened that a hacker who's trying to crack into a system looks elsewhere for a more easily accessible attack target. And it's not that difficult to harden VFP. I know a lot of you have. I don't intend to focus on some of the old tried and true and proven technologies. What I'm going to try and do here is focus on things that have changed in the last few years, or new concepts that have come up like SPD and IAM, which we're about to get to. So people can see that often with just a few lines of code, they can get themselves into a position where they have a perfect answer if asked, what does your system do about X, or how do you cope with Y? Okay, IAM, it's a fancy pants way of saying that we want the right users to have access to the right things. And it really boils down to login, because 85% of data breaches involve humans, and about 2/3 involve their credentials. If we have time, we'll get into that. So for VFP developers, we're talking about the login or sign in to our applications, and also not leaking things like error logs that might contain in the clear sensitive confidential information, or anything which allows a hacker to actually hack using Notepad. The other point is you're not responsible for all security around your application. If there's security available from the operating system or database, you should use it, and that's a perfectly valid response. Okay, so we're talking about identity and access management. Most people in VFP have got password type logins. We'll come to those. But what the proponents of multi-factor authentication say is if you have more than one mode of login required, you can almost eliminate the 65% of these breaches that involve credentials, because the hacker may be able to guess or crack the password, but they're not going to have the second authentication. So there's lots of different options. They are covered in the paper. I know that some clever VFP developers have managed to get SMS multi-factor authentication going, and various other options. But as it says in the paper, the market is actually turning away from text messages or even emails, both of which can be hacked relatively easily. I don't know about you, but on my phone, if I receive a text, it flashes up briefly on the screen, even if I'm not logged into the phone. And I can actually see my bank's SMS code when they when they text it to me without having to log in. So if you can imagine, a hacker who's got access to the locked phone actually can still access that multi-factor authentication. So what I've put in the paper, and what I'll just briefly show you now, is this is an example of the kind of multi-factor authentication which is very accessible for VFP. It doesn't require you to store any additional information whatsoever. And in fact, once it's implemented, the device that it's implemented onto doesn't even need to have internet access or mobile coverage to be able to function as an MFA. So that's quite good. So what happens is this uses Google Authenticator, and there's a few points in the paper about Google Authenticator. You can read those. But the bottom line is that the user has Google Authenticator on their phone, and you present them with this fancy barcode. They scan it using Google Authenticator, and that then gives them a little encrypted channel. And from then on, Google Authenticator every 30 seconds gives them a 6-digit code. And when they're logging into your application, you ask them for that 6-digit code. And using this API, in order to make that function, I would have had to have gone to Google Authenticate and done it. What we'll do is I'll just show you that. So the pairing, you pass your application name, which you can specify, you pass the user's name, and you pass a secret code. And when you do that, this URL generates this barcode. Your user scans it, and then when you validate it, when they enter the 6-digit PIN into your system, you hit a URL at the same site, and it tells you whether that's a valid code. So to recap, in order to generate this pairing, you would need to hit an HTTPS link passing your application name, the username, and your secret key. The user would scan that into the Google Authenticator. When they log into your application, they open Google Authenticator, read the current code of Google Authenticator, enter that into your system, and you then hit another URL which tells you whether or not that's a valid code. I wonder whether I can actually make this work just as a demonstration of it. Don't want to waste too much time on it, but it'd be nice if I can. Okay, I've opened up my Google Authenticator. If I go validate, if I try entering this code, okay, so that actually demonstrated that the system at work. So in terms of your VFP application, you could either use Rick Strauss www.http.prg or Craig Boyd's Connect FLL, or whatever you use to hit the internet. You pass one URL which generates the pair. Now, if you're feeling particularly clever, you can have a look at this, and you can actually see that this URL is actually relatively straightforward. It's got an HTTPS, and all this API has done is it's put an authentication key here, and you then get a nice image coming up. You could actually bypass this API and do that yourself, but this is so easy, there's no point. And then when the user enters their code, you can simply hit another URL and it verifies whether or not it's correct. So you don't need to store any keys at your application. You don't need to store what SMS got sent. You don't need to store their phone number. You don't need to store email addresses. and you don't even particularly care what device they've got Google Authenticator running on. Google is now responsible for all of that. And basically with a few lines of code, you've now got two-factor or multi-factor authentication. So that's not particularly difficult, and that is a good example of the ways that VFP developers can make themselves look really good. If someone says, what about multi-factor authentication? Why, yes, we can certainly do that. And in the paper, I've actually covered some of the other commercial options. They're mostly quite expensive. And I think in 2022, while I'm reluctant to give any recommendations, any firm recommendations, I do think that Google Authenticator is a relatively accessible and easy thing that we can do to impress customers. All right, moving on, just a few other things. I said I didn't want to dwell on old stuff, and this is old. But look, null attack surfaces, there's an example in the paper, and there's a little screen that's included. And basically the deal is it's worth reviewing code just to make sure that if someone manages to sneak in a null, it doesn't allow a false success state in your application. I'm not going to spend time on that. SQL injection, look, I will just put a little bit of time onto that because apparently not everyone has heard of it. So basically SQL injection occurs if you're concatenating strings and using those as SQL. So here's an example here, if I just expand this out. So hopefully you can read that. This is an example, a very standard example of a concatenated string. You've got your select statement, and then you've built in a variable of some sort, which is derived from customer input. So if we run that, so you get select star from dbo.customers, where customer code equals A1012. Off that goes to the SQL server. It all looks relatively innocuous. And what's the problem? Well, the problem is that if users are able to enter something like that, let's see what happens now. Okay, so this time, where customer code equals A1012 or 1 equals 1. Well, since 1 always equals 1, this query now pulls all the customers in the database. Welcome to SQL injection. So what your hacker has done is they've converted your SQL query from something which pulls one customer, which belongs to the user. You've actually pulled every customer, regardless of whether the user should have access or not. Even worse, look at this one. Okay, so semicolon indicates to SQL Server there's more than one TSQL going on here. So it pulls a bit of data, but then this updates the customers and sets a customer name to oh no for a condition which is always true. So you can imagine the malicious hacker has just changed 1 million customer names to oh no. We could have a sweepstake on how long that's going to take to cause consternation. And, there's nothing except referential integrity in a well-designed database to stop a hacker putting a drop table or a truncate or something like that into their string. But there's no end to the mischief that somebody can cause if you've got a SQL injection attack surface in your application. So the good news is there's no need to expose yourself in that fashion. And in fact, by default, VFP is SQL injection proof. If we look at this one, so this is a VFP parameterized query. So rather than concatenating the string, you put variables with question marks in front of them, which tells VFP that it's a parameter. And the remote view designer, since day one in 1995, has always produced parameterized queries of this form and update queries of this form. So anybody who used remote views has been SQL injection proof from day one with no effort. And everybody else, if you're using SPT or any other form of SQL, it's worth going through and just making sure it's not concatenated and it is using parameterized queries. You'll agree with me, this is actually easier than concatenating. And there's a number of other benefits. So, for example, anyone who's ever done SQL against Oracle will be aware of the slightly complicated transformations needed to convert a VFP date for Oracle. But if you pass it as a parameter, that's all taken care of for you. In fact, it doesn't even care whether it's a date or a date time. It gets transformed properly to match the database. Same with SQL Server. And the other point with SQL Server is that if you've got a parameterized query being fired through where it's only the parameter that changes between users, that gets cached at the server and its performance is almost impossible to distinguish from a stored procedure. So extremely efficient. So if you haven't, go through and just make sure that your code is SQL injection proof. And if you have, well, good, well done. Few other things, temp file locations, by default, VFP will put them into the TMP or TEMP environment variable. That's actually bad news for us. Increasingly, IT experts and security experts insist on the temp folder being virus scanned because it's a favorite attack vector for payloads downloaded from the internet or via email. And it's really the only reliable place where a hacker knows that they can put their payloads. So they insist on virus scanning. Problem for VFP is that it creates its own little temporary files, which it assumes it has exclusive access to. And on a very busy server, or where you've got multiple processes running at once, VFP can attempt to access its little TMP file right when the virus scanner has got its hooks into it, and you get a file access not available error and your application crashes. So if that's a busy web server, your customer's not going to put up with that for long. So have a look in the paper. You do not want to have a separate config.fpw just so that you can specify your own locations for temp files. There's a huge security risk because it allows the hacker to use Notepad to put a command in. VFPA has a technique that allows you to change your temp folder location at runtime. So you can put it into any file, you can establish your own application folder, and that one doesn't need to be virus scanned. Last but not least, check your error logs. In my case, the error log function was written almost 30 years ago after reading a book by Lisa Slater, which had a really good error log handler in it, which would list the memory, so all the memory variables and all the open tables up to 25, if you remember. Imagine that, what a lot of tables to have open at once, which was perfectly respectable and reasonable back then, but is not now, because you need to be careful what variables are in scope. You could be revealing sensitive client information or credentials or anything disastrous. And that could be in the current contents of a table if you've put that in your error log, or it could be in your list memory if you lose list memory. There's a few ways to avoid it. You can release variables that you know are sensitive. You can change variable names that are sensitive to all start with LX or something, and then do a release all like LX as part of your error log. You can put them into properties of objects. There's lots of different ways to secure information to make sure it doesn't go into the error log. I can tell you, if a hacker is able to embarrass your customer because of clear confidential information in an error log, you can expect severe criticism. All right. In the interest of time, cracking on. Cryptography, key part of any discussion of security. Just as a recap, hashing is a one-way algorithm that converts a plain text of any length into a fixed length hash. I say one way because there's no way or no easy way to get back from the hash to the plain text. And it's commonly used for things like credential checking, so for password checking and file integrity. And that's opposed to encryption, where you absolutely do want to be able to get back from the ciphertext to the plain text, but you can only do it if you know what the key is. Okay. Couple more jargon terms. Diffusion, also known as avalanche effect. What that's saying is to be cryptographically secure, you expect that if one bit in the plain text changes, there's an avalanche of half the bits in the ciphertext will also change. And that complexity is what makes it cryptographically strong. And it's the lack of diffusion that makes the old-fashioned character ciphers, you know, where one character change in the plain text causes one character change in the ciphertext. That's very easily hacked. And if you're anything like me, you can spend a lot of time looking at cryptography, and usually whether or not it's cryptographically secure boils down to the diffusion. I mean, it's a good proxy for cryptographic strength. If it's diffuse, it's very likely to be secure. Okay, so hashes that exhibit diffusion, MD5, I'm sure you've all heard of that. SHA 512, a bit newer and bigger, and AES and Blowfish, other industry standards for encryption. We are very fortunate in VFP that Craig Boyd delivered us VFP encryption.fll, and I'm going to give some examples using that FLL as we move along. Here's something you may not know. MD5 is not safe anymore. Okay, so MD5 was produced in the early 1990s, and basically in 2022, Moore's law has been applying. Moore's law saying every 18 months the power of a computer doubles. Moore's law has not actually applied in the PC world for a while. It appears to in the Apple world, but not in the PC world. But even so, there's been a lot of 18-month periods since 1991. The bottom line is that an MD5 hash for an 8-character password can be cracked in a few minutes. It's a slightly theoretical risk because I don't think very many of us hash just the password. If you hash just the password, it means that a low-level hash can be copied to an administrator account, and now a hacker can log in using that. So most of us have compound plain texts which incorporate a bit of username, maybe a bit of date or something else in the user table. The principle being the longer the plain text, the more secure it is, just as they talk about the power of compound interest, even if the interest is only a few percent. Cryptographically, every additional character is the equivalent to 650% interest every year. So you don't need to be a genius to figure out how that spirals up into the multi-millions and billions of potential complications. Okay, if MD5 is not secure, the risk if you're doing a compound MD5 is probably not huge, but why argue? Just update to SHA 512. If you're using VFP encryption, then it's actually very straightforward because it's just a single character change in the in your call to VFP encryption. So I've got some examples here. So if we just run these, So what it's showing is this is MD5. So MD5 produces a 16-character hash. A 1-bit change in the 16-character hash causes an avalanche effect. So this is cryptographically strong, but unfortunately easy to brute force. To change this to SHA-512, you change that 5 to a 4. And now we get a longer, but still avalanche affected hash. SHA-512 is said to have more available combinations than there are atoms in the universe. So we can hope that that will remain cryptographically safe for at least a few years. Okay, so if you want to change from MD5 to SHA-512, just be aware you can't do a batch replace from MD5 to SHA-512 because, as we've discussed, it's a one-way algorithm. There's no easy way to deduce the password from the hash, so you can't do a batch update. But in the paper, there's a few lines of code, very basic code, showing the kind of thing you can do. So next time the user logs in, if they're still on MD5, if they log in successfully, it gets changed to SHA-512. So you get a kind of a ripple of updates going through your system. That's definitely worth doing. No great hardship. When someone comes to you and says, why are you using MD5? It's insecure. You say, well, all we have to do is increase the length of the field to 64 characters, and this application immediately starts using SHA-512. Okay, password templates. Running out of time, I'm not going to dwell on this too much, but the problem with human beings is if you look, there's a couple of sample passwords there. If you require upper lowercase numerals and special characters, there's a huge proportion of users will capitalize the first letter, they'll add a special character on the end, and they'll use a common word with a common substitution. There are some examples there. I suspect there will be people watching here today who will think, oh, that's actually something I've done myself. We all do. We're human beings. The trouble with that is that modern brute force applications do not plod their way through every combination, starting with 0 at each character space and plodding up. They have dictionary attacks, and they check common words, and they check common substitutions and capitalizations. And those passwords shown there can be hacked in seconds. So, in actual fact, templates is all very nice, but it's the length of the plain text which delivers the most strength because of the compounding power of it. And the current cryptographic recommendation is to use 3 or 4 words, often separated by spaces, and that gives you your length, and that's cryptographically very secure, unless someone's so stupid as to use the names of their children, of course, but not much we can do about that. And the other thing to think about is salt and pepper. Salt is the addition of random characters. Pepper is the addition of a stereotype string, same every time. You can't use salt for an MD5. You can use pepper though, and you can use salt and pepper for encryption as long as you pass the salt in some fashion with the encrypted string so that it can be converted back afterwards. All right, now what I'm getting is people coming to me with really quite extravagant demands for how they want passwords to be handled. And in the paper, there's a couple of ways that you can actually transfer some of those obligations to the active domain and the operating system, which then becomes responsible for templates, frequency of changes, and whatever extravagant expectations are raised. And if Microsoft can't meet them, oh, that's no good. But the customer now needs to call Microsoft, not you. And we'll just go through that. Now talking about encryption, we've talked about MD5. AES 256 and Blowfish 448 are very cryptographically secure. They are both easily available using VFP encryption.fll. However, the default ECB is not secure. And this image you can see there is called the ECB penguin. That is the Linux emblem, and it's got lots of blocks of repeated content. When you encrypt using ECB, what it's showing is ECB is actually leaking quite a lot of information about the plaintext. Because what you'd really want to see is something like that. Now, ECB in many implementations is the default encryption mode. It was the simplest. It's called ECB because it mimics the old manual electronic code books where you would encrypt each block separately. And that's what ECB does. It divides the plaintext up into blocks. In AES's case, the blocks are 16 bytes long, and it then encrypts each of those blocks as a single encryption effort independently of what came before or afterwards. You might say it stands to reason that that's not secure because it means that if you change one bit in the plaintext, that's only going to change one block of encryption in the ciphertext. If each block is being encrypted separately without regard to anything else. And you're right. Sometimes I wonder how these things happen. But the bottom line for us is that ECB is also the default in VFP encryption. So if you're doing encryption only passing the plaintext and the mode and the password, you are encrypting using ECB and you are using a cryptographically insecure cipher. And you will be pulled up on it. And in fact, a lot of government departments and big organizations are now specifically disallowing ECB. You can actually tell if you're using ECB, if you're encrypting something like an XML string or sometimes a PDF. Basically, if you're encrypting material that's got a header and the header exceeds 16 bytes, then that means the first block is going to be the same in every event. And when you encrypt, you're always going to get the same first block ciphertext. And a hacker will take one look at that and say, number one, oh, that's ECB. And number two, I wonder what they're encrypting. Could it be XML? And they're well on the way to cracking your apparently secure cipher. Okay. What we'll do is we'll just briefly have a look at, here's some examples here of changing from, if you're utilizing this kind of encryption in VFP, then you're actually using ECB, which is a shame. If you don't want to use ECB, you've got to provide a lot more parameters. The last parameter is something called an IV, or initialization vector. And what makes other modalities apart from ECB so secure is they've got an IV, and the IV is used, it's XORed against part of the plaintext, which then gets encrypted. So it introduces complexity, or confusion as it's sometimes called, and makes it much harder to crack. It also means that every time you encrypt the same string, you're going to get a different result. So it destroys the leaking of information about the plaintext. We could run that, but I can just see time's getting short, so we're going to box on. There are other hacks that are available against encryption algorithms. The padding oracle, it's not about a database. It's basically quite clever. And it relies on the ability of a hacker to repeatedly submit ciphertext and to be told if there's an error in the padding character at the end. So AES and Blowfish, or no, actually Blowfish isn't, but AES is a block cipher. And what that means is it has to have 16-byte blocks to encrypt. So if the last block is less than 16 bytes, it gets padded out to 16 bytes. And in the same way as if you know what the first few characters of the plain text are, you can start to do a crack. Knowing that the last few characters are padding characters can also allow a crack if you can get the system to behave differently if one of the padding characters is invalid. So you basically start changing characters in the last block, submitting them, and if you imagine someone playing cards and their face lights up when they've got two aces, that's called a tell in card playing. It's called an oracle in cryptography, and it basically means that a change in behavior is able to be interpreted. The bottom line is that this exploit theoretically allows you to crack even one of the more secure ones using an initialization vector. You can crack the entire plain text without even knowing the key. The good news for VFP is if you're asked about padding oracles, the correct answer is look in the paper. VFP encryption doesn't produce padding oracles, and if it doesn't produce them, it can't publish them. So VFP encryption, if you break one of the padding characters, it just distorts the plain text, and there's no change in behavior. There is no oracle. You cannot use the exploit. In the paper, Microsoft last month came up with another version of it using timing. You may get asked that by a security consultant. The same answer applies. There's no timing difference in VFP encryption because it doesn't care about the padding character. All right, and you're going to get asked, does your application support secure connections? Well, if Microsoft has its way, you've got no choice because they're making it compulsory. The correct answer for the application is that all of the prevalent and accessible forms of encryption are not handled by your application. They are transparent to your application. And the latest, and in my opinion, best always encrypted option, as of SQL 2016, that's available to all editions, including SQL Express. And it means that the data is encrypted from the moment it leaves your ODBC connection all the way into the database where it remains encrypted at rest. Very secure. It needs the certificate at the server, as does all of these things, but that's not really your application. And it also needs the ODBC drivers installed on clients. If we look at ODBC, so these will be familiar to most people. Your native SQL Server clients, and I can't see them, but these ones here are the ones that can handle always encrypted. So rather than SQL Server native client like that, it's changed to ODBC driver. And I think the ODBC driver 13.1 and later can all handle always encrypted for all editions of SQL Server. So you'd need to install that ODBC driver on the client machine or the server that's using it, and then you would need to change your connection string to utilize that rather than that. But I'm pretty sure that most people have got their database access in a format that makes it relatively easy to change. That is not a hard change. Okay. DEP compliance. It's a big deal. DEP compliance means that the execution of malicious code is blocked except in spaces of memory that are declared as being for execution. So you can't download a payload into the memory of an application and cause it to run. No VFP is not DEP compliant. It's too old. VC++ 7.1 predates it. But all x64 apps are DEP compliant because they've got to be compiled with 10 and later. And VFPA does have an x64 version. So if you can distribute the VFPA 64 version of your product, then yes, you can be DEP compliant. Interestingly, last month, Mr. Chen released a 32-bit version of VFPA, which is now compiled with VC10, and it is DEP compliant, but they ran into some incompatibilities with old stuff, and for now it's reverted. I would not be surprised if VFPA allows a confident yes to this question before long. Just remember, though, that your FLLs are still going to be back in 7.1. You're still going to need those runtimes. Okay. Developers versus hackers. Compiled classically meant it's converted to machine code the processor can run. Interpreted, there's a separate runtime which analyzes it. Those terms have gotten mixed up. In classical terms, compiled applications need great skill to pick apart, whereas interpreted is relatively easy. So .NET with its IL and VFP with its tokenized code, very easy to pick apart. That says summary, but what it actually means is it's time to look at some other interesting things. So what I'm going to do is, people complain about VFPs having a slightly old-fashioned IDE, but check this out. So this is OllyDBG. It is one of the oldest and most venerable hackers. And the reason I use it is because it has plugins and options from the old days that would be considered irresponsible these days. It's not the only available. Okay, it's not showing here. Microsoft has got a very attractive debugger called WinDBG or WinDBG preview, which looks beautiful, but I don't think it's as good as this for what I'd like to show you. So what I'm going to do is, OllyDBG allows you to connect to a running process using attach, or you can actually fire up a new instance of an application, and you can then have a look at it. What I'm doing here is I'm firing up a prepared application, which is a VFP app. And here it is. Very straightforward. So what I'd like to show you is how easy it is for an application, if it's got a debugger attached, to read memory. So here's the memory map for the application. You don't need to understand all of this. These are specific. So OllyDBG only allows 8-character owners. Sad how old it is, but it doesn't matter. Okay, so but if you have a look, all of the memory that is being utilized by this running VFP application, all of the dependencies, all of the declared DLLs, everything has got a little memory block. And what I'm going to do is I'm going to search for driver equals in the memory, because I'd like to see if I can crack a connection string. And there's none there. Let's create one. Okay. Oh, right. What's happening is you can't. Oh. Whoops, that was a bit silly. Let's try that again. So it brings up a dialog. So now the variable PCCon is set to driver equals SQL Server, yada, yada, yada. You get the idea. And come into here. There you go. I've just plucked your connection string out of memory. Oops. If we now run pccon equals empty string, let's run pccon equals empty string. Oh, that was a shame. I meant to actually leave it there. Oh, there it is. Okay, so it's gone. So you can easily conceal a string in a VFP application by setting it to blank. Let's bring it back. Let's find it. There's no guarantee it's going to get put in the same place. So there it is. This time, let's release it. And let's look for driver equals. Okay, so either blanking it or releasing it appears to be a reliable way of hiding a string. So that's good news, isn't it? Let's try the local version. Well, we'll just do a clear memory first. So what this done is it's set a local variable lccon. It's set it to driver equals SQL Server. Let's see if we can find it now. lccon now, okay. This is actually, so the way VFP works is that when you run an executable or an application, VFP, the runtime actually downloads your source code into memory, or the tokenized version of your source code into memory, and it executes it there. And so in this case, there could be more than one way of finding the driver, because the obj code fields in the screen have to be downloaded into memory in order for VFP to run them, and you may be able to find the driver there, which is what I've just done. So there's multiple ways of finding it. Now this one's the string. So let's see what happens when we go out of sync, when we go out of scope. So declared at the beginning of the click for that button, it's now gone out of scope. In VFP, it's gone. In memory, it's still there. So putting things out of scope using local variables is not sufficient. What about that? Now it's gone. Sys104 is flush. So look, I'm sorry we don't have much time. What I'm basically showing you is the deal is you keep variables in memory for the shortest time possible. Don't rely on them going out of scope to hide the content. Release them or blank them. In actual fact, because of the way VFP works, you might consider actually, rather than blanking it, replacing it with spaces of the length of the current string or one less than that, because VFP then won't reassign a new block of memory. It'll just put the spaces into the same space, and that variable is now eradicated, and you can then release it if you want to. So that might be safer. The other thing to watch is, and I can't show that now, if you're using expressions, expressions can lurk in VFP memory for a very long time. So VFP appears to utilize little bits of memory when it's doing concatenations and other expressions. So the best advice is don't concatenate variables into themselves if it involves secure content. Create a new variable. If you concatenate strings into themselves, VFP assigns a new block of memory and the old one can be left sitting there. So what you want is you want to create new variables which you can then release at the end, and it will clear them. If VFP assigns a new block of memory and you then release or blank out the variable, it doesn't do the old one as well. That basically sits there until VFP sees fit to do a cleanup. So probably at the end of everything, you might consider doing a sys1104 to clear things out. And then the job for the hacker is to try and they have to kind of intercept the functioning of your applications so that they can lift things out of memory while they're still present. So you've made it a bit harder. You're not leaving telltales around, and you're not leaving connection strings for long periods of time in memory. By the way, it doesn't matter if it's in a property of an object. It's just as accessible in memory. OllyDBG doesn't care what VFP thinks it is. It doesn't care about scope. It's just got access to the memory. So that's how easy it is to lift things out of memory, unless you've thought about it. Just close that. All right. Gosh, I'm going to go a little bit into the question time, sorry, because some of the stuff I want to show you is quite good. All right. So that's how people can pull stuff out of memory. The other one, though, is if you have a look, I'm sorry, I had it open, but of course I've managed to close it. We come into here. It's unfortunately very easy to pull information out of a VFP application. So I mentioned earlier, the way VFP works is when the executable runs, the runtime takes the VFP source, which is stored in what looks like an APP. It downloads that into memory, some or all, just like a VFP table. It doesn't all have to come at once. But I think in modern machines with plenty of memory, it usually does. And then it executes it in memory. Now, this happens whether you've wrapped it in Refox. It happens, it doesn't matter what you've done. In the end, in order for a VFP executable to run, it has to be downloaded into memory. And unfortunately, that creates an exploit called the memory hook. And the memory hook says, if you can get code to run inside the VFP thread or application space, you can access that memory and you can download it onto disk. And then you can convert it comes across as a kind of an APP. You can then use Refox or other applications to actually restore the source code. So in view of time, I'm just going to show you. This is showing how you can unprotect a DFox 4 application. DFox 4, it's a real shame Leonard stopped developing DFox because it's actually a really good system. So what I'm going to do is I'm just going to bring this across here. Now, I know this is a little bit hard to read. I'll make it a bit easier. Hopefully that's better. Okay, so this is Refox, and as many of you will know, Refox allows you to click onto a VFP executable. It doesn't actually matter whether you've used the encrypt setting or whatever it might be, and it becomes possible. Sorry about the flashing. That's something to do with I'm having to use remote access to access this copy of Refox. So you can actually access the entire underlying application in seconds using Refox unless you've applied some kind of special encryption. If we look at this one, this is a DFox application that I've unprotected. And if you look in here, now these are things that Leonard adds to the application himself, and it explains why DFox is actually such a marvelous protection scheme. So this gets added to the beginning of your executable, and it actually creates some properties which can be used for debugging, and it also messes with the memory space utilized by VFP so that things that used to work the ability to scan memory and pull VFP applications becomes an awful lot harder using dfox4. So, really very clever. But, oh, no, not that one. I almost disconnected my application. So it's pulled apart. And if we have a look in here there's some other functions here. We can pull things out of refox. We can pull things out of VFP C++ compiler. You can also pull things out of memory. So you can use OllyDbg to find and download the VFP application if you want to. And you can then pick that back into an application. In a way, it's good that we're out of time because I'm not sure how much of this you actually want to show.
John, you actually have 15 more minutes.
Oh, okay. All right, I got 15 minutes. All right, good. So let's just utilize that time then. What I've done is the trick is just minimize it to stop it flashing. Okay. Here, isn't it? I'm going to run OllyDbg again in that case. And I'm just running OllyDbg. So I'm running it as an administrator because, okay, my fingerprint reader doesn't want to work. Okay, this time I'm going to debug VFP itself. Okay, so OllyDbg is now debugging VFP, which, by the way, some of the newer debuggers can't do. Oh, it's still not running. Hang on, not finished. Okay. I cannot see the command interface. It's because it's on the other screen. Bear with me. Okay. So what I'm going to do is, if you look at OllyDbg, I showed you before, you can actually see in the memory map every dependency and DLL is present here. So if we go back into here and go set the library to VFP encryption.fll, we now look in here. I can't see it there. So VFP encryption.fll is now utilizing memory. Like a VFP application, a DLL or FLL, which is a DLL, needs to be downloaded into memory. And problem, oh, somehow I managed to jump off it there. If we click in there, the problem is if you're utilizing an external library, that actually provides a very convenient breakpoint. A breakpoint in a debugger means that it replaces a byte, usually 1 byte, although it can be more, of code with a special kind of interrupt vector. And believe it or not, the 8086 and so the 086 processors all the way up to the i7s and the rest of them have all got hardware assistance for debuggers. So basically when that interrupt vector fires, the operating system intercepts the running of the application at that point and transfers it to the debugger. So a breakpoint consists of storing what was there and replacing it with your interrupt vector, which is usually a CC byte, by the way. And when the application runs, when it hits your substituted value, bang, you're back in OllyDbg. So I don't think you need to be a rocket scientist to figure out if I can detect when someone utilizes VFP encryption, and I can cause a break to occur in OllyDBG at that point, it's highly likely that the encryption key or the string being encrypted are going to be available in memory at that point. So that's quite a severe security risk. It doesn't just affect VFP, it affects all applications. So really the only defense against that one is you want to try and limit the easy breakpoints for the hacker. And unfortunately, that is an easy one. So what I wanted to show you was if we, everything's in the wrong screen. Let me just bring this across here. Okay, so if we go into, unfortunately, I closed the one was already positioned there. But if we go into, I've produced a project here called, it's an inline VFP project. Just give me a moment while I find it. It's not scan memory. I'm embarrassed I can't find what I wanted to show you. So what I've done is I've prepared a VFP C++ application which does have, it inlines the encryption so that rather than calling a separate function, it's actually inlined right there in the program. I think what I've done is I've produced it using my other login, and unfortunately it's not available to this demo login. So I'm sorry about that. What I'll do is I'll upload it with my paper so that people can access it. What will happen now is I'll suddenly see it. Just give me a moment. No, I'm not seeing it there. It's called inject memory, and I'm not seeing it at all. Okay, I've put it somewhere inaccessible. I'm sorry, I can't show it to you. But using VFP compiler, you can inline encryption right there in your PRG. So you can have VFP code running along, and then when you want to encrypt or decrypt something, you use a special VFP compiler inclusion, which allows you to include the material at that point. I'm just racking my brains here as to where I could have put it. That's it. That's the executable. So is it here somewhere? All right. Well, okay. So what happens is that when you're utilizing VFP encryption, it obfuscates when you're using VFP compiler, it obfuscates your code, and what it leaves in the VFP executable, which can be memory hooked, same as every other VFP, is something like this, which is basically a series of unfamiliar, confusing commands, and most of the work is now being done inside a companion C++ DLL. If we have a look at them, okay, that's, oh, there we go. Okay, so goodness me, we actually changed the size of my screen shortly before we came in here. I wonder if that's part of the issue. So basically, with VFP compiler, you end up with an exe, but also with a companion FLL. The FLL for a typical business application is going to be several megabytes in size, and the hacker now needs to decompile a C++ DLL of several megabytes in size to try to find a suitable breakpoint at which they can intercept your password. So it's very much harder. So it means that it's much more likely using VFP compiler that when you temporarily establish your variable, perform the encryption, and then destroy the variable, it's much less likely that the VFP compiler, that the hacker is going to be able to guess how to do that. All right. I'm sorry I can't show it to you. It was prepared. I just can't see it. Maybe we'll try that. There. No, that's not it. That's SQL injection. No, it's just not here. All right. I'll ask the organizers to upload the VFP C++ compiler version to with my paper. And people who are interested can use OllyDBG and do what I did and see whether you can intercept the credentials in the VFP compiled version versus a standard VFP app or a refoxed. It's the same if you've got stuff wrapped inside Thinstall or Armadillo or anything else. In the end, in order for VFP runtime to be able to run your VFP application, it has to unload it into memory in a certain format, and that is a recognizable format. And while, you know, the Thinstalls and so forth can make it hard to put a hacker on the outside, to put a debugger externally to get in there, they can't stop VFP code running inside your instance. So people will be aware of if you're using a report, well, reports have events. You can put your exploit code into an external report. If you're using external local tables, you can add the table to a DBC and put, you know, before open or an after open, or one of the DBC underscore events can be set with your exploit code. If someone's so foolish as to put a config.fpw in the clear, you can add it in there. And if none of those work, you can actually introduce a modified VFP runtime, which runs your exploit code. And in the end, you are going to be able to pull the VFP project out of memory, save it as an APP, and depending which technology you're using, the hack tool, the hooker, may itself be able to restore programs and screens and so forth. Or you might have to go to refox, but it takes minutes. So that's the reason I like VFP compiler. It doesn't stop the hacker hooking the VFP application, but you don't care anymore. It's gibberish. All right, well, I think we're very close to time now. I don't know whether there are any questions or anything else anyone would like to look at?
Just a couple questions. Do you have any code to show in VFP for two-factor authentication?
Well, look, I could probably write some on the fly. If you're familiar with Westwind, Rick was the speaker immediately before me. But if you're familiar with his classes, there's a WWHTTP class which contains a number of functions where really once you've declared his or you've set procedure to his PRG, with a single line of code, you can perform an HTTP hit, and the response can be displayed to the user. If you're clever, you can actually pull the image out of it. Alternatively, you can put it into a web browser control and show it to the user. I haven't prepared any code for it because it's literally just a few lines. If you look at that API, it's you'd need to hit the URL and grab the response, and the response actually includes a URL to a Google URL, and that's where the image is. So you could just display that in your in a web browser or in a browser even. It doesn't actually matter, because what happens is when it's displayed, the user just needs to scan it with their Google Authenticator. I don't know whether you've had a look at Google Authenticator, but basically you can add an application in Google Authenticator, and you scan that barcode, and that then puts into Google Authenticator a little bit of metadata. And from then on, without needing access to the mobile network or to the internet, every 30 seconds, Google Authenticator creates a new key and displays it to the user. You would need to introduce a new input for the code, but that's not going to tax anybody. It's a 6-digit code, and you then send that 6-digit code to another API, which is defined. I'm sorry, I've closed the web browser. I'll show it to you, but it's defined on that page. And actually, in the paper, I've actually put, there's a GitHub repository where you can actually download the source code for the Authenticator API, and you can put it on your own server rather than using that one. And that would allow you to make a few cunning changes. But no, I haven't done the source code. When I experimented with it, maybe earlier this year, early in January, February this year, I had it going in about 2 or 3 minutes. I handed that over to Dev, and they've carried it forwards. I assume that they've done some sort of screen or class to input the code from Google Authenticator, but I haven't checked. But certainly the API part is very straightforward.
Okay. Just one other quick question. I think are there multiple versions of Craig's VFP encryption FLL out there?
Yeah, there are. The initial one he did is VFP encryption, which he renamed to VFP encryption 7.1.FLL. And that one's compiled with VC++ 7.1, which is the same version as VFP. But he then did another version using VC++ 8, and that one's now called VFP encryption. That one, some of you will know, VC++ 8 had some unusual requirements. You had to have a special manifest folder that had to have a number of files in it. So it was a little bit more complicated, but it has not been compiled since then, which is a shame. It would have been nice if it had been compiled in something newer like VC++ 10, but it hasn't been. Some years back, I think it was maybe 2010, it might have been, we did a challenge over on Foxite for cracking people's applications, and Craig gave me one to crack, which I did crack. I actually asked him at that time whether he would mind open sourcing his VFP encryption.FLL source code, but he wasn't willing. At that stage, no, that's too strong. He didn't think that was something he would be wanting to do at the moment. Maybe it's changed since then, and maybe we could get it recompiled in VC++ 10. Even if you do, though, you're still going to have that exploit I showed where OllyDBG can tell you the moment that FLL is accessed, bang, you get a breakpoint, and you can then go and sniff for credentials. So if you can, you want to eliminate that possibility, and one way is to put everything into one big fat VC compiler, FLL or DLL, which the hacker then needs to pick through to try and find where would be a good place to put your breakpoint.
Okay, that's all.
Okay. All right. So I'm sorry I couldn't show you inlining in VC. it is in the paper. There's a couple of snippets of source code in the paper showing that working. I will need to ask Mr. Chen whether he minds my putting the actual inclusion C code in the Fox Pro header. So there's a C++ header, and there's two snips of C code that get actually embedded at that point in your VFP PRG. Those usually only come with the paid version of VFP compiler. I would need to ask whether I can put those up there. But as long as he's happy, I'm happy to do that. And I can also put a VFP C++ compiler executable up there, which has got inline encryption and decryption. And you guys can have a crack and see whether you can intercept the credentials. I don't know whether I've gone quiet or you guys have.
Nope, that's it. We're all done.
Okay, all right. Oh, well, I'm afraid the curse of Rick struck me as well. Where in God's name have I put that? I had a prepared executable. I just can't see it. Oh, well. Oh. Have I cut myself off? No.